Before I start working through this example, I need to define a few keywords here that will help us to understand what you're looking for in this question. So the word constant term and the word term, the words term independent of x, they mean the same thing. These words here mean basically the term in x to power 0. So the term in x to power 0. And we know that x to power 0 is equals to 1. So basically, that means that whatever that term is, it will be a constant term. It will be independent of x. Okay? It will be just a number without a variable. So that's why they are called constant terms or terms independent of x. So because it's a specific term, what we need to do is we need to use the general term formula to find that specific term. And before we write down the general term formula, we need to write down the binomial expansion formula or the binomial theorem. And the binomial theorem goes like this. A plus b to power n is equal to whatever comes first plus the general term, which is given by this formula, plus whatever comes next. So by inspection in this question, a is equal to 4x cubed, b is equal to -2 over x squared, and of course n is equals to 5. So the first step is to write down the general term. So the general term is 5r, because we don't know what r is. Our a is 4x cubed to power 5 minus r multiplied by -2 over x squared to power r. But what we need is we need the term in x to power 0. So we need to find the term in x to power 0, which means that the combined powers of x are 0, right? So the combined powers of x are 0. So what we're going to do is we are going to focus only on powers of x, and these powers of x should be equal to 0. So from the general term, we have the powers of x, which are given by x to power 3 to the power of 5 minus r multiplied by 1 over x squared. Remember, I'm just focusing on the powers of x, and this should be x to power 0. So because all these powers should be equal to 0, because we are interested in the term in x to power 0. So let's simplify this using laws of indices or exponents. So x to power 3 to power 5 minus r multiplied by x to power -2 to power r will be equal to x to power 0. So what we shall end up with here is if we just equate powers of x, we'll have 3 into 5 minus r minus 2r is equals to 0. So 15 minus 3r minus 2r will be equal to 0. 15 minus 5r will be equal to 0, or we can say 15 is equals to 5r. So r will be equal to 3. So which means now we can write down the specific term that we want. So the term in x to the power 0 in x to the power 0 is given by, and we can write this from the general term, which is 5, 3, 4x cubed to the power 5 minus 3, because r is 3, multiplied by negative 2 over x squared to the power 3. And we can simplify this. This is equal to 5, 3 multiplied by 4x cubed to the power 2 multiplied by negative 2 over x squared to the power 3. All right, 5 choose 3 can be calculated from our, can be found from our calculators. So 5 choose 3. So that will be 10. So you have 10 multiplied by 16 x to the power 6 multiplied by negative 8 over x to the power 6. And you can see that this case here will cancel, and that's why it's called a constant term. And what you'll end up with is negative 1 to 80. Now, because r is 3, it means that this term is actually a fourth term, okay? Because r is 3. Although that's not necessary, but you just need to know that when r is 3, then you have a fourth term. But this here is the constant term. In this example, we are required to find the term that is independent of x in the expansion of 3x squared minus 1 over 2x to the power 9. Now, the term that is independent of x is basically the term in x to the power 0. It means the term in x to the power 0. So this is a specific term, which means we need to use the general term formula from the binomial theorem. So basically what I mean is the first step will be to write down the binomial expansion formula, which is a plus b to the power n is equals to whatever comes first plus the formula for the general term in this expansion, a to the power n minus r, b to the power r, plus whatever that comes next. So we can clearly see here that by inspection, a is equal to 3x squared, b is equal to negative 1 over 2x, and n is equal to 9. So all that we have to do is we have to plug this into the general term formula to find the general term. So the general term in this expansion is 9r 3x squared to the power 9 minus r multiplied by negative 1 over 2x to the power r. So we need to find the term in x to the power 0. So the combined powers of x will be 0. Okay? We need to find the term in x to the power 0. So the combined powers of x will be 0. And that's the strategy that we're going to use. We're just going to focus on powers of x, and from the general formula, general term, the powers of x are x to the power 2 to the power of 9 minus r multiplied by 1 over x to power r, and this should be equal to x to power 0. And if we simplify this, we are going to end up with x to power 2, 9 minus r, multiplied by x to power -1 to power r is equals to x to power 0. And we can equate the powers of x, which means 2 into bracket 9 minus r will be equal to 0. And we can carry on to simplify this. So that will be 18 minus 2r minus r is equals to 0. So 18 minus 3r is equals to 0, which means r is equal to 6. So the term in x to power 0 will be, so the term in x to power 0 will be, and this is actually written from the general term, because now we know what the value of r is. So the term in x to power 0 will be 3x squared to the power of 9 minus 6 multiplied by -1 over 2x to power 6. And you just need to simplify this. So that will be 9 choose 3 can be calculated from our calculator. So 9 choose 3 which will be 84. So that will be equal to 84 multiplied by 3x squared to power 3, because r is 6, so actually you can replace that with 6, which will be 3 multiplied by -1 over 2x to power 6. Anyway, let's simplify this. So this will be 84 multiplied by 27x to power 6 multiplied by 1 over 64 x to power 6. So the x to power 6 will cancel. Those will cancel. And our answer here will be 567 over 16. Now, because, and again, this is just an extra step, because r is 6, this term will be the 7th term. I know this is not necessary in this question, but it's just important to know that because r is 6, this will be the 7th term in this expansion.